Thank you for joining this talk about sustainability. So if you are here, it's because you care about the climate change and you care about sustainability, so thank you for joining us. First of all, let me introduce myself. I'm Marc BERTOMEU. I love photography. I took this picture on 2008. I also love run marathons. I was finishing in Berlin Marathon. And as I'm getting older and older, I'm running slower and slower, but I'm getting more experience in IT. And I also love IT. So I'm working for 20 years in IT, 7 years at ING as a software engineer. And I define myself as a software developer that loves databases.
Hello, everyone. My name is Alexandru Mădălin-Ghenea, and as you can see, I love nature. I really enjoy going on walks and on hikes. And besides that, I'm also a software engineer at ING. I've been working at ING for around 6 years. I mainly work with backend systems, and I've been programming since I was 14 years old. Like probably everyone here, I also enjoy a good challenge. And what better challenge than climate change? We hear about climate change every day nowadays in the news, and rightly so, because climate change is accelerating. This summer has been the hottest summer on record. Besides that, 8 out of the last 10 years were the warmest on record. We can see a graph on the right with the global mean temperature since recording has started, and we can see that the temperature has been steadily rising and actually accelerating. We can see with a red square the last 10 years. Besides that, another record was broken this year. The sea temperature was the highest on record. Again, we can see it with black on the graph, and we can see that it's a significant increase. And also, the last few years were also increasing. The temperature was increasing.
Let's talk about TAS. Let's talk about information communication technologies. ICT represents between 3 and 5% of the global carbon emissions. This more or less, it's the same level of emissions than the aircraft, than the aviation. So aviation represents 3.8 Europe, in Europe, more or less, it's European Parliament. The source is European Parliament, and worldwide around 3% of global emissions. There are a lot of figures, a lot of numbers. It's difficult to figure it out because sometimes logistics are included, sometimes only commercial airlines or passengers, sometimes even army is included or excluded. So it's difficult to get the right number, but it's more or less 3% of emissions. So we are more or less at the same level. The consumption, the energy consumption of ICT in 2020 was 7% out of the worldwide energy, and half of this share is just consumer devices. So our laptops, our smartphones, our TVs, our streaming services. Also, operation of data centers is 15%. It's where we can take some action because we are all developers, so we run our applications in data centers and also in consumer devices. So we have some room to improve and we can take some action. The expectations for 2030 are pretty hard, so we will increase 50% of this energy consumption, meaning that our share will be 13% worldwide, and the operation of data centers will be doubled, 30%, and there is an attention point about networking. Network will appear in the picture. Before it wasn't, now it's in the picture, and it will be more or less 27%. This is due to the cause of the increase of streaming services and also Internet of Things. But we have to be fair. Also, our industry is contributing to reduce emissions. So every time that we take the car, for example, to come to this conference, if there is a traffic jam or there is any impediment, our GPS will route us to a more efficient route. Logistics, every time that a package is delivered, it's delivered by using the most efficient path, thanks to the ICT services. Smart meters also allow companies in real time to generate the energy that is really needed in real time. So this is something that we are also, these kind of services, we are providing from ICT and are contributing to reduce the CO2 emissions. But our own CO2 emissions are significant and growing, so we can take some action.
So we saw that we have a serious challenge ahead of us. For the rest of the talk, we will cover the following topics. We will first introduce some key concepts, which will help you get the most out of this talk. We will introduce the software carbon intensity, which is a formula that we will use throughout this presentation. Then we will have a look at some green patterns, tips and tricks, and suggestions that can help your application be greener, such as demand shifting, some suggestions for storage, and we will also have some demos related to performance improvements in code. And last but not least, we'll have a look at some conclusions. Let's start with the key concepts. For this talk, we will introduce carbon awareness, carbon intensity, and as I mentioned, software carbon intensity. In order to understand what carbon awareness is, we first need to understand what are high carbon sources and what are low carbon sources. In the context of this talk, we're referring to high carbon sources when we're talking about carbon sources that produce a lot of CO2 when generating electricity. You can think of coal plants or gas plants when we're talking about high carbon sources. On the other hand, when we are referring to low carbon sources, we are referring to carbon sources that produce few or zero CO2 emissions when generating electricity. You can think of solar panels, windmills, nuclear reactors, and so on. Now that we know that, carbon awareness basically means that we do more with our application when energy comes from low carbon sources, and we do less with our application when energy comes from high carbon sources. In other words, we use our application more when energy comes from, for example, some solar panels, and we do less with our application when energy comes from a coal plant. Next, we'll have a look at carbon intensity. And carbon intensity means basically how much CO2 is emitted per kilowatt hour. We say that we have high carbon intensity when a lot of CO2 is emitted per kilowatt hour, so when energy comes from, for example, a coal plant, and we say that we have low carbon intensity when few CO2 is emitted per kilowatt hour. So we can think of a windmill or a solar panel.
Let's talk about software carbon intensity. First of all, if you can't measure it, you can't improve it. There is a lot of discussion about this saying. Some people say that things like attitude and stuff like that cannot be measured and can be improved. But in terms of CO2 emissions, in terms of consumption, measuring it's something that we really need. So if we need to track if we are doing it well or not, we need to measure. Green Software Foundation, it's an organization that developed a formula to measure the software carbon intensity. We really recommend you to register or to check this organization because they are developing really nice trainings and really nice things about carbon intensity development. They proposed this formula. Software carbon intensity equals to the energy consumption, normally in kilowatts per hour, multiplied by the intensity of the carbon emitted of energy, normally grams of CO2 per kilowatt hour, plus the embodied emissions through the hardware where we are running the software, so the emissions that were emitted to produce our server, our laptop, or our piece of hardware where our software is running, and everything divided per functional unit. For example, per user, per device, transaction. So let's say that we are running a service, login service, so it will be divided per login. If we are running a delivery service, it will be divided per delivery. This formula will drive our presentation. You don't have to memorize it. We will remind this formula during the presentation, showing some examples on how can we help to reduce our software carbon intensity with some suggestions. This is to take away. There are tools to improve the efficiency of our applications in cloud. You can take it. The slides will be available at the end. We will show you a QR code linking to a GitHub repo, so you will be able to download the slides. Also, you can check it in YouTube. So for cloud, code, and web, you have tools to improve your, to make more optimize your applications.
Now it's time for some green patterns, some suggestions and good practices that can help make your application more carbon aware and greener. And we will start with demand shifting. Demand shifting basically means reducing the carbon intensity of your application. There are two types of demand shifting: spatial shifting and temporal shifting. First, let's have a look at spatial shifting. Spatial shifting basically means moving your application from a high carbon intensity region to a lower intensity region. Let's take an example. Let's imagine that we have an AI model and we are deploying that AI model, let's say in the US, as we can see in the image with the blue marker. The region where we are deploying has high carbon intensity. In order to reduce the carbon intensity, we could deploy our AI model to another region that has lower carbon intensity. For example, we could deploy it to Spain where there is a lot of sun and a lot of solar panels, so the overall carbon intensity will be lower. Of course, like everything, this has trade-offs. Different regions might have different policies for privacy and security. Different data centers might have different carbon footprint and carbon intensity. And last but not least, by moving your application farther away from your customers, you might have an impact on latency. We promise that we will come back to the SEI formula. And for spatial shifting, we reduce the overall carbon intensity by moving to a lower carbon intensity region. The second type of demand shifting is temporal shifting, which basically means that we run our application more when the carbon intensity is lower. A good candidate for time shifting are recurrent jobs. Here is a non-exhaustive list of recurrent jobs, such as batches, queuing non-urgent requests, machine learning training jobs, OS updates. For example, Windows 11 can be carbon aware, so it can do its updates based on the carbon intensity. It can detect when the carbon intensity is lowest, so it can do the updates then. And for all these recurrent jobs, you could use some carbon aware time scheduling. So you would get a forecast when is the lowest carbon intensity and do these recurrent jobs then.
Let's say that you have a report that you need to know the sales to pay the sales staff at the end of the month. You are running this report on 15th of the month. You don't need this report for now. You can defer the execution of the report. So you don't need it for now. You need it in the next 15 days. So you can choose to run this heavy processing in low carbon intensity periods. So it's a message. So the real time, I want it everything for now. It's something that maybe we should start to think about. What it's really needed for now and what it's really needed for after some time. Doing that, we will reduce the intensity because we will run our applications doing lower carbon intensity periods.
Now, let's have a look at some suggestions related to storage. The first one is quite obvious: delete unused data. So if you don't need it, just delete it. You could set storage retention policies that will help you automatically delete the unneeded data. Besides that, probably almost everyone here is using CI/CD pipelines, and of course these pipelines are generating artifacts when releasing the application. So you would have some packages and executables, and when you're developing some new feature or just playing around with the application or testing it, you will run these pipelines and you might generate additional artifacts. Once you finished playing or developing the new feature, you can delete these artifacts. Another way would be to set the appropriate log levels. So if you have an application running in acceptance or staging environment, maybe you don't need debug level logs, or you can have a look at your application to see whether or not you need all the logs that the application is generating. Maybe you can reduce there as well. By reducing the amount of storage needed, so deleting the unused data, it means that we have less embodied carbon overall. So less data needed means that we have fewer storage volumes and in the end, less embodied carbon.
Let's now go to practical examples. Let's say that we need to get some data, we need to store some data. The one of the most efficient file formats is Parquet file. We don't know if we know, but we are starting just to show some ideas or suggestions. So if you move your data and your application, it's able to work directly with Parquet files, you will save a lot of space. So this is data about the trips of taxi, yellow cab, coming from the New York City Hall. So this is data. This is real data. This data in CSV, the size in a CSV file, it's 70.8 megabytes. In a Parquet file, it's 11.7 megabytes. And from CSV and Parquet files, you can already work with this data. So it's a file that allows you to interact with the data that contains. But if you want to store the data or you need to transfer this data quite often, you may choose to compress this data from CSV file. 7-zip, it's really efficient compressing, but it's adding an overhead with this compressing and decompressing operations. So choose your trade-off, get the best of these figures. Look, for example, this case is pretty curious. This Parquet file is 38.1 megabytes, and compressed it's even bigger. Okay? So it's not worth it to compress a Parquet file, but it's small enough to store it efficiently and also to work directly with it. Consider to change some other file formats. XML can be changed to protobuf. GIF can be changed to MP4, JPEG to WebP. Consider to use SVG. This is really, really efficient. Also, you can embed your SVG in your HTML or your CSS, saving some requests to your server. Of course, optimize image sizes for your site or whatever you need to do with these images. By doing this, our emissions will be lower because we will use the overhead only when we really need it. And also, our embodied emissions will be also reduced because we will need less storage.
Now, it's time for some performance improvements in code, so some demos. But before we go actually into the code, we want to tackle the SEI impact, because for all the demos that we're going to show, it's going to be quite similar. Basically, all the demos that we will show will improve the energy consumption by running optimized code, and also having efficient code can mean less hardware. So let's start with our setup. For our Java applications, we are using Epsilon garbage collector, which is a no-operation garbage collector. We are using it to minimize the impact from the garbage collector action so that we have more consistent results in our tests. We are also fixing our CPU frequency, again, for more consistent results. We will use IntelliJ Profiler in order to see the memory footprint and the CPU usage. Besides that, we will also use JewlerGX, which is a tool that can provide the energy consumption of your Java application. And for the demos related to databases, we will use PostgreSQL on Docker.
I think I told you at the beginning that I'm a developer that loves databases. So let's go through a database, very first demo. First of all, I will make sure that there is no table left in the database, just to don't have any kind of storage. And in the meantime, this script is running. I will explain what we are doing, how we can optimize this. This is the data that I told you before. It's just the yellow trip. It's the yellow cab, the trips of taxis in New York. These are the columns. This file, it's a Parquet file that we showed before. Postgre can read only from CSV, so we had to convert it to CSV. You saw before the size, the difference in size. And this table, it's the situation, tries to reproduce the scenario that we will find in a real life. Normally, we have our tables with our indexes and our constraints there in place. After creating the table, all the indexes and all the constraints, remember that a primary key is also a constraint, meaning that it's an index, it's a unique index in the background. We load all the data in the table. Now, let's run another approach. I will drop the table that we created. So this table took 39 seconds. Now let's drop the table to don't have any issue with the space. And now I'm going to run another approach. Okay. The table is the same than before. The file that we are going to load is exactly the same, but this time we will defer the index and constraints. So we will create everything, all the indexes and all the constraints, after the data is loaded in the table. So what we are doing is just loading all the data, and then when all the data is loaded in the table, we create all the indexes and all the constraints. You saw it right now, this took 21 seconds. So it's, I think, almost twice, okay? Normally, it's a good approach, or it's much faster if you have to do your ETL operations, extract, transform, and load operations. Normally, it's better to use tables without any kind of restriction or any kind of structure. It's normal to have indexes to optimize or to speed up our joins, filters, but it's a good practice to create the index when the data is created, because the index also will be better balanced. You know, every time that you insert a row, the index needs to be rebalanced, and there are operations related to each and every modification in your data. So the index will be more balanced, and the storage will be more compact. There will be less defragmentation. Tips to solve this: defer the index creation after loading the data, as we did, but if you cannot, because you already have the tables in place, maybe your database management system allows you to disable the constraints, so you can disable everything, you can put offline the indexes, load all the data, do your changes, and then re-enable the restrictions and rebuild the indexes, or just putting online. So that's a good practice that will speed up your process of loading data. Let's move to the next demo, which is...
Yeah, now we will quickly see a really simple demo related to pre-allocating the right collection size. So we will go to IntelliJ, and we have a really basic demo where we just insert some elements to a collection, in our case, a list. We are doing this in two different ways. First, we will just create a list, an array list in our case, and we just insert some numbers to it. We have 15,000 numbers. We also put some loops there, so it will run 10,000 times, so that it's more like running with a load, let's say. Then the second option would be, probably most of you know that you can instantiate the list size, the initial list size at creation time. So we can specify here we want an array list with an initial size of 15,000. And that's the only difference that we have between the two demos. Now let's run it with the profiler. And this demo is really basic, but we're mentioning it because maybe sometimes you might forget about this small thing. And yeah, in a few seconds we will have the results. And yeah, we have the results. We see that the two, they're really the same from a CPU point. Yeah, a really small difference. Sometimes one is a bit faster, the other one a bit slower, and so on. But that's not where the big difference is. The big difference is in memory allocation. We see that the non-pre-allocated collection method took 2.53 gigabytes, while the pre-allocated one only 600 megabytes. So it's a big difference here. So the takeaway of this small demo is that if you are working with some collection and well, a large collection, and you know the initial size or the approximate size, you could maybe specify it. It can improve in lower memory footprint.
Let's go to the next demo. Let's go back to the database. By the way, everything that we are showing, it's pretty technology agnostic. So the example with the database, it works with all databases, or almost all databases. And the example that we saw in code, it works not only in Java, but also other languages. So let's move to another scenario. Now I'm gonna use the last table that we've created. I'm gonna add a column saying is cheap, okay? And as I did before, I will run the scripts because this will take a while. I will create two functions. I will describe. In the meantime, this is running, and then I will call these functions. Okay. Now, what we are doing is we've created a column saying if is cheap. And what we want to do is just set up the value, the proper value to the column. If it's the value, it's the total amount, it's greater or equal than 15. We will say that it's not cheap, so we will update as n, and otherwise we will say that it's cheap. We will consider that it's a cheap trip, okay? Now we are using a cursor, so we loop through all the rows. This table has more or less 2.5 million almost rows, so it's a pretty big table. But real life, it's even more complex. And also, you may have other operations running on the database. And the only thing that we do is just loop all the rows and update the value depending on some condition. That's all. This is based on a true story. So we had a migration process coming from one database to another database. We had to transform the data to adapt to the database to the new version that we were rolling out. And the initial approach of the PL SQL, in that case it was Oracle, not Postgres, it was based only on cursors. Cursors inside of cursors, nested cursors, and more cursors. If else, for, okay? To try to speed up this process, we just rewrite everything to queries. So instead of using cursors, you can think, instead of programmatical way, you can think in a semantical way, and you can translate what are these cursors doing to some queries. So in this case, this cursor can be translated to these two queries. So we update the table, say we set if is cheap to n, if total amount is greater or equal than 15, and to yes, if the total amount is minor than 15. These two queries will run much faster than cursors, because queries mean implicit cursors, but the database manage everything, faster and in a more optimal way, everything that is managed implicitly than explicitly. This is now Postgre, but the real example was in Oracle. So I think now the function finished, and we can see the trace of this function. So the first one took 1 minute 13 to loop all the table and update the values, and the second one took 53 seconds. Of course, this is a really basic example. As we said, real life is more complex, but you will have more nested cursors. So as the more cursors you get rid of, the faster will be the query or the whole process. So the takeaway is normally queries are more efficient than cursors. Nested cursors can also be translated to queries and subqueries. So things will be more complex, but it's worth it to make the effort. The most unused feature of SQL databases is normally SQL. This was said by Thomas Kite of Oracle. So take the most of your SQL database by using SQL queries. Let's move to the next suggestion. Let's go to Hibernate.
Now we'll have a look at a small demo related to Hibernate. So let's select it. And basically for this demo, we will just insert 1,500 rows to a table, to a simple table called persons. That table contains 3 fields: surname, name, and ID. So nothing special there. We can quickly check the configuration. Again, nothing special. We just see some properties for connection, and then the dialect, which is set to Postgre. Now I will quickly run the demo so that we will have the results by the time I finish explaining. So we are running it now, and we decided to do the inserts in different ways. The first approach is to do a single commit. So here we have a for loop. We are just creating some dummy data for some persons. So we're just creating some persons. And at the end, we do the transaction commit. So at the end, we push to the database. Another approach would be to do commit per insert. So each time we create a person, we then do a transaction commit. So we push to our table. Yet another way would be to use HQL, so the Hibernate query language. We can see here the HQL command. We set the parameters, and at the end, we do the transaction commit, again, pushing to the database. Yet another way to do it would be with session. So we are opening a session in Hibernate, and then we are creating each person, and at the end, we are doing the session flush and clear, so we are pushing to the database. A variation of the session approach would be to use a batch. So we are using a batch size of 500. And basically, this means that every 500 people, we are pushing them to the database. And last but not least, we decided to also have a look at a simple approach with JDBC SQL driver. So We see here we only have a statement, an insert statement, really simple, nothing special here. We are setting the parameters, and at the end, we are doing the commit. So now let's see the results. We can see that the first approach was okay. I mean, not the greatest, not the worst. A bit over 400 milliseconds. Then the one commit per insert was a lot worse, with over 2.5, so 2.6 seconds. The HQL one was even worse in this case, with 4.5 seconds, and the session ones performed a lot better. Well, they are usually more or less the same. Sometimes we see the other one performing a bit better. This is, of course, not a benchmark. It's just to get a rough idea. But the most performant in this case is the SQL approach with the SQL driver, which makes sense because we are using less layers, let's say. We can quickly also see the memory allocation, and we see again that the commit per insert uses more memory. I mean, it was expected also for performance that this will not go that well. We see that the HQL approach also performed quite bad, but the rest did not use that much memory. We can also quickly have a look at regex, so to see the power, the energy consumption of our application. So I will copy the ID. Well, actually, it's this one, so we know it here. I'm gonna quickly go and see our measurements. We also see here that indeed the commit per insert and the HQL one are the worst performing, while the rest are performing a bit better. The values might vary a bit because maybe sometimes the connection is not closed immediately, so you might see a bit some differences between this and the profiler. Basically, the main takeaway of this demo is that well, Hibernate is a really nice tool. It can make our life easier, but you need to pay attention how you use it. You might do it in different ways, and some of them might be more performant than others. And maybe in some cases, you can also use directly a SQL driver, which might be more performant.
Let's move to the next demo. No database anymore. Now let's talk about regex. When I was a student, I didn't like regex, and now I still don't like it. And someone told me, if you want to be an elegant developer, you should validate through regex, blah, 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 blah. Okay, indeed, there are some complex validations that deserve a regex, that's true. But let's check a real example, real one. So let's say that we have this expression, well, this regex expression, and we want to validate if there are some language and region tokens in some string. That's all, okay? Let me run in the meantime. First of all, what we will do is we will just validate straight using the matches, okay? Then we will increase a counter if it matches the pattern or not. All the functions do the same, just to show that they are returning the same result. Next, we will use compiled validation because we will pre-compile the regex expression because it will speed up a lot, okay? And indeed, we will validate the same amount of values. Next, what we will do is just to use a code validation, the one that we did when we were students, you know? And the code validation, it's simple as is. So it's just a return. We check if the string contains these tokens that we are looking for, and that's all. Another thing another attention point is to be fair with the regex validation. Here we are not limiting the length of the string, but it's a very good practice to limit the length of the string. This will make your code also safer, in terms if you are getting attacked in a DDoS attack, it's really easy to put really, really big strings and take the benefit from the attacker perspective of the slowness of the regex. So always, whether if you use regex or code validation, always first validate the length of the string. Then you are always safer. But even if the string is small, regex validations normally are slower than slower than just code validation. Of course, there are some complex regex that deserve, there are some complex validations that deserve some reg expression, but you see here 10 seconds, 9 seconds, the precompiled, which is not a big benefit, and just 36 milliseconds, the validation based on code. Same strings, okay? Also, if we check the memory consumed, we will see that code validation is not even appearing because it's less than 1%. When it's less than 1%, the profiler doesn't print the consumption. So it's really efficient. So this will make your code faster, safer, and of course more optimized. So when we were students, maybe we were right. Let's go to stream.
Yeah. Next, well, it's let's say a small use case that we will show. It's related to stream because we already saw the setup. For this one, we will just go through the slides. It will be a bit faster. And here we have the problem statement, which is a simple one. Just find if there is a number larger than 12 in a very large list. And yeah, here is one way to do it. It's very inefficient, not the way to do it, definitely. So basically what we do here, we filter on elements that are larger than 12, then we create a list, and we check if the size of that list is bigger than 0. Maybe the ID is smart and might say, hey, instead of using size larger than 0, use isEmpty. Sure, we tried that. It's still not efficient. We could do it in a different way. We can use maybe count and just count the number of occurrences. And if it's larger than 0 again, we have our answer. But again, this is not an efficient solution. A better solution would be to just use any match, of course. And we can also see here the values from such a run. We can see that it's not even a competition. Any match took 8 milliseconds, while the rest took a lot longer. So between 1 and 2 seconds. And it's also important to note that the first two also are allocating another list. And if it's a large list, then yeah, we also might have a big list allocated, in this case 1 gigabyte. So the main takeaway here is that if you're using any feature like stream or whatever else, or a framework, it's good that you should know its functionality and not misuse it. Because as you can see, it can have a big impact.
Now, question for you. We are almost all Java developers, so we know what this endpoint is doing. It's just an endpoint that will return OK if the endpoint is alive. The question, what's wrong here, it's not correct. The question is, what can be improved here in this bit of code? For simplicity, we didn't put any if, else. It's just a single value, but you could have maybe a few conditions or, I don't know, 3 possible values. When you know that your API may return only a few values, how can we improve this? No ideas? Well, that could be. But let's check this. So do we really need every time a new instance per each call to return the same value? This will allocate a lot of memory, and also if it's a high concurrent endpoint, this will make a difference. Really, it makes. What can we do? Exactly. That's an approach. Maybe there are others, but if we keep a singleton, if we use the singleton pattern, or we just keep by keeping a static instance, we will return always the same value on the same object. This will be much more optimized than the previous approach. Stream Builder. Stream Builder is also something known. We are not going to show it here, but of course, if we are talking about performance, we have to mention it. We are not going to demo it, but everybody knows, as Java developers, that strings are costly. String is immutable. Every time that you do some operation with a string, you are getting new instances. If you need to concatenate a lot of text, use Stream Builder instead of strings. No demo for that.
So now we are slowly approaching the end of our journey together. And well, to recap, we saw that we have a serious challenge ahead of us, and it's crucial that we make a difference also in IT, because we saw that IT has a significant impact in overall CO2 emissions. But there is good news. There are a growing number of tools, resources, and solutions that can help us take on this challenge. We saw some of them in this talk. We also saw some suggestions that maybe inspire you to see whether we could improve your application. And we also saw some tools that can help you measure your application consumption. Besides that, we would like to mention again Green Software Foundation. They were a huge inspiration for our talk, and they have a lot of interesting resources and information there, so please check them out. They're really, really great. So yeah, if you're interested. Yeah?
Can I ask something? How are you doing right now in the sense of increasing energy consumption at ING?
We are tracking. We are starting to monitor our data centers, so we know what's the CO2 emissions. Of course, we don't have everything now in place, but we are taking track. We are measuring our data centers. Also, all that we mentioned in this talk, these are actions that we are taking. So, for example, for the storage, we are starting to consider to clean up all the binaries that we used only for testing. We are starting to clean up emails that people are just storing forever. So some emails you won't need it for the rest of your life. So we are taking some actions, more or less what we are saying, so taking care about efficiency in our code, in our developments, taking care about storage, also measuring. We cannot, because it's something pretty confidential, but we cannot show you the data of our data centers, but we are measuring the CO2 emissions of our data centers.
And basically, that's the first step, as we mentioned.
Yep.
First, need to measure to know what we can improve. If we don't have the values, then yeah.
Can I
Yep.
a suggestion, even without sharing any metrics, you could say that, for example, like the benchmark is 100 in 2022, and then in next year you dropped to say 80 or 90.
Yep. Maybe next year we will have more figures. We can measure the progress. So maybe next year we will show some figures. Maybe in the next coming months you will see some products that are also green or let's say emissions aware. Maybe in some time you'll see something. So keep an eye in our website, because maybe we will release something related to awareness of emissions.
Okay. Shall we continue?
Yep. Please.
Yeah.
It's me. Yeah. So that's something that we mentioned before. So do we need everything for now? Maybe the real time should be something that we should use only for things that we really need real time. So try to slow down everything that we don't need it for now. We don't need to process it now. Think about everything that we mentioned in this talk. It's about small changes, but these small changes make a big impact. So that's, I think, a good example in real life. So everything that we do when we sort the trash, it has an impact. It has big impact. So 50% of the composting of municipal waste is recycled, and everything starts on the action of sorting the trash. So if we start taking care about the performance of our applications, how we store the data, how we transfer our data, and what we do in our data centers, or everything that has energy consumption, with these small changes we can translate this to a really big impact. So we can save the planet bit by bit. So we have also things to do. We can take some actions. And as promised, that's the last slide. So you have the QR code with a link to our repo in GitHub. Everybody knows how GitHub works. So you can open and pull requests, issues, suggestions. If we did something wrong, please tell us that we did something wrong. We are human, so we might be mistaken in something that we mentioned it in this talk, or maybe something can be improved, or maybe you have other ideas that can be also that can complement this set of suggestions that we just proposed in this talk.
One more thing to mention: the slides will appear also in the repo later today. And well, if you have any questions or you just want to say hi, you can find us at the ING booth. Thank you, and we wish you a very nice conference.
Enjoy the conference.